So, good evening, all of you. So, in this practice session, we are going to complete the third chapter, that is current and electricity. We have already discussed few questions. Now, we will complete this particular topic. So, as you can see, we have summarized this chapter and then we have discussed up to question number 15. So, let's start with question number 16. Now, see, question number 16. Let's see the question first. Question number 16. Is this storage battery of EMF 8 volt, internal resistance 0.5 volt is being charged by a 120 volt DC supply using a series resistor of 15.5 ohm. What is the terminal voltage of the battery during the charging? What is the purpose of having a series resistor in charging the capacitor? So let's see. Let's solve this question. So try to solve this. Let's see the solution of question number 16. So EMF is given. Let's see question number 16. So EMF is 8.0 volt. Internal resistance is 0.5 ohms. And there is a DC supply V is equal to 120 volt. Having a series resistor of 15.5 ohm. Series resistor is 15.5 ohms. So what you have to find, what is the terminal voltage of the battery during charging? So in this case, let's see. This is the series resistance R and this is 120 volt. And this will be the small r. This is EMF. This will be small r. So this current will flow in this direction. That is the direction of current. And what is the effective voltage in the circuit? So let's see. What will be effective voltage in the circuit? So if net effective voltage is, because this is minus plus, this is minus plus. So if your current is I, apply KVL in this loop. Let's apply KVL. So this will be plus minus. This is plus minus according to the direction of current. So you will get I into R minus 120 volt plus E is 8 volt plus 8 plus I into R is equal to 0. So what will be I? I is given by 112 volt divided by R plus R. So this is 15.5 plus 0.5. So in this question, it is given that battery, this is charging case. So this, when current is flowing in this direction, this is the charging of the battery. When current in opposite direction, it is discharging case of the battery. So that's why I have taken this particular polarity, because this storage battery is charging. So what will be current I? This will be given by, this is 17, this is 16, and this will be 7 ampere. This will be 7 ampere. So current in the circuit is 7 ampere. Now what will be the voltage drop across R? What is voltage drop across R? VR is I into R. So 7 into 15.5. And this will be given by, so this will be 108.5 volts. 108.5 volt. So what will be the, this is the voltage drop across R. So what is the terminal voltage? So terminal voltage is this voltage. Let's say this drop is V dash. This whole drop is V dash. So terminal voltage is given by, is terminal voltage V dash will be given by, what will be this voltage? Because drop is 108.5. So this is 120 minus 108.5. So this is 11.5 volt. This will be 11.5 volts. This is the terminal voltage. And the R will simply limit the current. Without this R, current will be very high. So use of this R is to limit the current. If R is absent, current drawn will be extremely high. So just to limit the current, we have used the resistance R. Is it clear? So note it down. Now we have question number 17. Just see question number 17. It is given that the number density of free electrons in a copper is 8.5 10 to the power 28 per meter cube. Question number 17. So number density is 8.5 into 10 to the power 23 per meter cube. It's a free electron. Copper is a metal. How long does an electron take? How does an electron take a drift from one end of the wire 3 meter long to its other end? So length of the wire is 3 meter. The area of cross section is area of cross section is 2 into 10 to power minus 6 meter square, and its current I is 3 ampere. So drift velocity Vd is given by L by T. How long does an electron take to drift from one end of the wire to other end? And I is equal to given as NEA Vd. So this is NEA L by T. So time T is given by NEA L by I, where E is the electronic charge. So N is given as 8.5, 8.5, 10 to power 23. E is 1.6, 10 to power minus 19. Cross-sectional area is 2 into 10 to power minus 6. Length is 3 meter. And divided by current is 3 ampere. So this 3 will cancel out. If you calculate this value, so that will give you 2 into 8.5 is 17 into 1.6 into, this is 10 to power minus 25, 10 to power minus 2. This is 10 to power minus 6. This is 10 to power, no, this is 10 to power 28. Please correct it. This is 10 to power 28. So this will be what? Plus 10 to power 23. 10 to power 3. 28 minus 25, 3. So if you multiply it, 27 this much second, or this will be given by 2.7 into 10 to power 4 second. This will be the time. If they are moving with drift velocity, time taken will be given by this value. So that is question number 17. Now solve next question. Question number 18. Let's see. Try to solve question number 18. So question number 18 is, so there is a 6 lead acid type of secondary cell, each of having 2 volt, EMF of 2 volt and internal resistance of 0.015 ohm joined in series to provide a supply to a resistance of 10 to power 5 ohm. So they are connected in series. What are the current drawn from the supply and its terminal voltage? So in question number 18, what will be current drawn here? So current I is given by, there will be 6 epsilon by R plus 6 into R, because they are connected in series. Yes or no? when there are n cells, they are connected having internal resistance R. So this will be N E by R plus NR. So just substitute the value. 6 into 2 EMF divided by 8.5 plus 6 into 0.015 ohms. So this value will be 12 by 8.5 123 0. This is 0.09. So this is 12 by 8.59 ampere. And this value is approximately 1.4. Approximate value is 1.4 ampere. Because they are connected in series. This is A part. In B part, a secondary cell after long use has an EMF of 1.9 volt and a large internal resistance 380 ohm. What maximum current can be drawn from this cell? So in this case, what will be the maximum current that can be drawn? So this will be simply E by small r. Because internal resistance is very, so maximum that current that can be drawn is E by R, because then external resistance will be 0. So this value is 1.9 volt divided by 380 ohms. And that will give you 5 milliampere. This will be 5 of milliampere. Clear? So that is question number 18. Now see question number 19. Question number 19. Now there are two wires of equal length, one of aluminum and other of copper, have the same resistance. Their resistance is same. Which of the two wire is lighter? Hence explain why aluminum wires are preferred over the overhead power cables. And it is given that resistivity of aluminum is given, resistivity of copper is given, and their relative density of aluminum is 2.7 and of copper is 8.9. So see question number 19. So their resistance is same. Resistance of aluminum, two wires of equal length have the same resistance. Aluminum and copper. Length is also same. Resistivity is given. This is the resistivity, and density is also given. So what will be the resistance? And let's masses will be aluminum and mass of copper. So what will be resistance? R aluminum is R copper. This is given. So R is equal to rho L by A. So this is rho L by A, area, cross-sectional area. So this is rho copper L A copper. So this length will be same. So you will get their resistivity of aluminum and copper. This will be given by this is Al by this will be the relation, and because this value is given, so what will be, this is Al, cross sectional area of aluminum by cross sectional area of copper is rho Al by rho copper. So this is 2.63 into 10 to power 8 divided by 1.7 into 10 to power minus 8. Both, this is also minus 8. Please correct it. This is also minus 8. This will be minus 8. So this will cancel out. Just there is a correction here. You can take it as a minus 8. So this ratio is 2.63 by 1.72. Now if we write mass, we know that mass is volume into density. Volume into density. So mass of aluminum is volume is Al into Al into density is dAl, and mass of copper is A into Cu L copper, density of copper. So this will give you mass of aluminum, mass of copper, because L is same, so that will give you A into Al, D into Al. This will be A copper, and this is D copper. This value we have already calculated, 2.63 by 1.72, and density is 2.7 by 8.9. And try to check this value. I think this value is approximately 0.46. So mass of aluminum is less than the mass of copper. So aluminum is lighter. So that's why this aluminum is preferred, because its mass is lighter in this case. Clear? So only correction is here. You can take this value is 10 to power minus 8 ohm meter. Please check and then solve question number 20. Let's see question number 20. Try to solve question number 20. Solve question number 20. So try to solve. So in PGT physics exam, you have to focus on the straightforward question. You should just remember all the concepts and formulas and just try to apply it. So that's why I'm taking questions that are that type of question is asked in PGT exam only. So our concern is how to crack the PGT physics exam. So let's see. So you can easily calculate. There are n resistors. Each of resistance capital R, how you will combine them to get the first maximum, then minimum effective resistance. So when you will get maximum, when you will connect it in series. So let's see. Question number 20. A part. So R maximum will be R plus R n times. So this will be n into R. This will be maximum value. And what will be the minimum value? So 1 by R minimum will be 1 by R plus 1 by R. So this will be n by R, n times. So what will be R minimum? So this is R by n. So this will give you R maximum by R minimum is nr by R by n. So this ratio is n square. This ratio is n square. So that is A part. Now B part. Given the resistance of 1 ohm, 2 ohm and 3 ohm, how we will combine them to get an equivalent resistance of 11 by 3 ohm. Equivalent resistance is 11 by 3 ohm. So how we will get 11 by 3? If you take parallel combination of 1 and 2 will give you 2 by 3. Yes. So let's take this. This is 1 ohm. This is 2 ohm. And then this will be 3 ohm. So because this combination will give you what? 2 by 3 and this give you plus 3, 11 by 3 ohm. So this is the first case. You want 11 by 3. Now you want 11 by 5. 11 by 5. So for 11 by 5, equivalent resistance is 11 by 5 ohms. So in this case, you have to take, this is 2 ohm. This will be 3 ohm. And then this will be 1 ohm. So this will give you 6 by 5 and then plus 1. No, this is 6 by 5 plus 1. This will be give you, this is 11 by 5. Yes. So this is 11 by 5 ohms. And in third part, you want 6 ohm. So for 6 ohm, they must be in series. Case 3 will be R equivalent will be, when they are in series, 1 plus 2 plus 3. This will be 6 ohm. And you want 6 by 11. In this is fourth one. So 1 by equivalent will be 1 by 1 plus 1 by 2 plus 1 by 6. So this 1 by 2 plus 1 by 3. 6. So this is 6 plus 3 plus 2. So R equivalent will be 6 by 11 ohms. Clear? So just you have to see how you will arrange them in series and parallel so that you can get the equivalent resistance. Now C part, you have to find in figure A and B. What will be the equivalent resistance? Let's calculate. Let's check the equivalent resistance in this case. Take 2 minutes and try to calculate. So in B part, in C part, just see, you have to find equivalent between these 2 points. So these two are in series. This is also in series. So this becomes 2 ohm. This becomes 4. So you will get this equivalent circuit. I'm writing here, this will be 2 ohm and this will be 4 ohm. This is 2 ohm and this is 4 ohm. And in same way, all are 2, 2, 4, 2, 4 and so on. This is 2, 4, 2 ohm, 4 ohm, 2 ohm and 4 ohm. So what will be equivalent between these 2 points? So these two are in parallel. So this equivalent resistance is 2 into 4 by 2 plus 4, 6. So 8 by 8, 16, 8, this will be 1 ohm. Two plus 4, not 6. This is 2. Equivalent will be 2 into 4 by 2 plus 4. So 8 by 3. This is for one particular case. So this is 8 by 6, or this will be 4 by 3 ohms. So one will give you 4 by 3 and they are in series. So R equivalent will be 4 into 4 by 3. So this will be 16 by 3 ohms. Equivalent will be 16 by 3 ohm. And in this case, they are in series. So this is figure A and this is figure B. So R equivalent will be 5R. They are in series. Equivalent between these 2 points will be 5R. So now you have one last question. You have to find the equivalent resistance. Determine the current drawn from a 12-volt supply with internal resistance of 0.54 by the infinite network shown in the figure. So if you know the equivalent resistance, you can find the current drawn. So first you have to find the equivalent resistance, and then you can there, if you apply 12 volt with internal resistance 0.5, you will get the current drawn. So try to find. How we will get the equivalent resistance, because this is a infinite network. So if you see between any 2 points, equivalent will be, let's say, R dash or R. So let equivalent resistance be R. Let equivalent resistance between these between 2 points of an infinite network is R. So if you are considering, because if you are taking at this point, you have R. If you are considering this point, because it's an infinite network, so its equivalent will be R between any 2 points. So now we can write this network as, let's say, 1. Now I'm considering these 2 points. This is 1 ohm. This is 1 ohm. And this is also 1 ohm. Now I'm replacing this infinite network by its equivalent resistance R. So what will be, and what is the equivalent between these 2 points? That is also R dash or R1, simply R, not R dash. You can take it as R. So this R will be given by, because at any 2 points equivalent is R. So this will give you, now these two are in parallel and then they are in series. So you will get 1 plus 1 plus R into 1 by R plus 1. Or this is R minus 2 is equal to R by R plus 1. So let's simplify this. You have R minus 2, R plus 1 is equal to R. This will give you R square plus R minus 2R minus 2 is equal to R. So this will give you R square minus 2R minus 2 is equal to 0. So this is minus B plus minus B square minus 4A C is minus 2 by 2A. You know how to solve the quadratic equation? So this will be 8 plus 12. So R is given by 2 plus minus 8 plus 4, 12. And 12 is given as 2 root 3 by 2. So resistance value is positive. So I am taking 1 plus minus under root. So this value is 1 plus under root 3. Take positive value and this will give you 1 plus 1.73. So this will be 2.73 ohms. This is the equivalent resistance. So equivalent resistance is 2.73 ohms. Now, what will be the current drawn if there is a R equivalent resistance between these 2 points and you have applied a voltage source of 12 volt with 0.5 ohms and this is 12 volt. So what will be current I? Current I will be simply 12 volt by 2.73 plus 0.5 ohm. So this will give you 12 by 3.23, and this value is approximately 3.72 ampere. So this value is 3.72 amperes. So that is all about the third chapter. You have to focus on these type of questions. We have already given you the summary also. Summary we have given you. So we have taken examples on each part. We have also discussed the Wheatstone bridge condition. So that completes the chapter number 3, that is current and electricity. Now next chapter is moving charges and magnetism. So in next week, we will focus on chapter number 4, that is moving charges and magnetism. So you should revise the chapter. I will give you summary, and then we will try to solve some PGT level questions. Clear? Okay then. Thank you. Thank you everyone.